Hey guys, so today I am going to be showing you guys our art enrichment that we're doing to go along with the PowerPoint I posted last week with Galileo. We're moving on to from Galileo's scope to the Hubble telescope. It's a big giant leap in some ways, and it is not a leap at all in others. The thing about telescopes is if from rudimentary to sophisticated to absolute brand new science, they all have the same basic components to them, which is uses of very, very large lenses and mirrors and the collection of light. So in keeping with our discover and develop ideas, I wanted to go ahead and do a quick art project with you guys that hopefully you have these materials around your house. If you don't worry about it. That's perfectly fine. But it gives us kind of a fun way to look into another scientific concept that's far more physical science, and that is the concept of chromatography. So in the concept of chromatography, what you're doing is you're taking something that is in solution and you're trying to pull it out into its component parts so you can study those components. I think that right now, especially in light of recent events, that chromatography is probably playing a key and very important role in us helping to understand the coronavirus pandemic, that we're having to look very closely at how something is in all of its components in order to understand how to fight it. So what we're going to be doing today are making chromatography star nebulas or chromatography galaxies. If you'd rather look at them that way, you certainly can. And all that you need to do this art enrichment is a marker. Crayolas or ones like this work the best for this application. However, you can use any marker and you can use any color. I'm using black because I know a little bit about color theory, and I know that black is going to give me kind of the result that I want, but you can use any color that you want. You need a white paper coffee filter. White is best. I also have the brown ones because they're more compostable, but for this particular project, white ones are best. You need a paper clip or a binder clip, and then you need a cup of water, okay? So I have this filled right about to there, okay? You need very small amounts in here. I'll have all of the procedures for this listed as a Google Doc. You do not have to copy anything in your notebook. This is really just for you guys to have at home, hang up on your fridges, all those good things, get you outside on a nice sunny day, and look into the concept of chromatography. So please do not feel like you have to turn in anything after this, because you don't, but I'd love to see pictures once you guys are done. So what I'm going to be doing is I'm going to be looking at Hubble imagery first. That's what I want you guys to do before you start this. And I want you to kind of go for an image that really speaks to you in some way. You think it's beautiful, or it looks really interesting. It looks really kind of sci-fi, whatever you're into. It looks like something you saw in Star Wars. I've not seen a single solitary Star Wars movie, kids, so I don't know the references. But I want you to try and find one that you like, and then pick the color of your marker if you can accordingly, and see if you guys get kind of close once it's processed. So what I'm going to do very simply is I'm going to take my coffee filter. Oh, I forgot to mention, in your materials you need a paper towel, guys. Don't try and draw this on your counter or on your kitchen table without having something underneath it, because that marker ink is going to go right through here. This is very, very, very porous. So I'm going to go ahead and put this down on my paper towel, and I'm going to draw a big black circle, and then I just did some squiggles around it. That took me 4 whole seconds. Okay, then I'm going to take this and I'm going to fold it until it is in a wedge shape, pretty much 16ths. So this is in half. Now we have quarters. After quarters, what do we have, kids? We have eighths, and then lastly 16ths. Okay, so then I'm going to take this, and I want to suspend just this little tiny tip of it in my water. Okay, I only want it to barely touch the top of the surface of the water. I do not want to dunk it. I do not want it to fall in. If I do, the chromatography will not actually happen, because We need the water to work through here, to suspend through here in order to pull that marker out into its separate pigments. If it happens too quickly, the pigments can't pull out the way that they need to. So you're going to want to make sure that this is barely touching the surface of the water. Okay, so I'm going to put this up here. And I'll actually do it down here just so I don't spill it on myself. And I'm going to clip it. It is barely touching, and I know that because it's going to start to saturate absolutely immediately. Okay, and then I'm just going to leave it there for a few minutes. While mine is processing, I'm going to go ahead and talk to you guys a little bit about how Hubble images are actually created, because it's something that before I learned about it, I kind of took for granted that it's just this big telescope out in orbit or in the solar system, and it's just taking these amazing pictures. That's actually not the truth. Hubble imagery is actually composite imagery. Remember that a composite is something that's made up of lots of different things. So Hubble images are actually created from lots of different data points. Hubble is taking UV data. It is taking infrared data. It is taking 3D imaging data. It's taking heat signatures. And then it's taking all of that information and it's putting it together with an artist's rendering of what the actual, taking all of that data, putting it together. What would that star, what will that protostar, what is that galaxy, what does that nebula look like if we take all of that information and we put it together in its giant expanse of space? And that is what we have when we look at Hubble imagery. They're incredibly beautiful, but what really they are is they're equal parts art and science. They're not just a scientific reading, and then, or it's not as simple as me taking a picture of you or of myself, and then it is true to whatever we took at that time. A lot of different data goes into it, and I didn't realize that when I first started my research on Hubble, but I found that was fascinating because I love art and science together. You guys know that. So as this is processing, I'm going to kind of show you a little bit about what mine looks like. I don't want to spoil it for you guys. I'm going to just show you what it is when it moves through correctly and quite slowly, and then I'm going to put it on my paper towel to dry. I encourage you guys, after this is all done, completely dry. Make sure you're drying it on the paper towel because you don't want to stain anything, including yourselves. Make sure you wash your hands after this, obviously. But once they're all dried, I want you guys to go ahead and put them up in your classroom spaces at home, put it on your refrigerator, put it in your bedroom if you're big into science and stars like I am. And I hope you guys enjoyed this chromatography project, and I'll see you guys in the next one. Bye-bye. Oh, no, I won't. Hold on. I'm going to show you guys mine. It's going to be wet, though. So, and I don't want to get it on my skirt. All right, so I am taking it out of my cup. Okay? And remember, I did a black dot. But if I look at this, I can see a bunch of other colors, can't I? So, in this case, this chromatography has pulled out several other pigments that do not appear to be black. They don't appear to be black at all. They appear to be kind of a teal blue, a dark blue. I'm trying to not rip it as I open it. Purple, green. So my black dot actually wasn't black at all. My black dot was green and teal and purple and blue and a little bit of gray. All right, so this particular pigment, my black pigment, was actually built with a lot of different types of pigments to make it appear to be black, much like how Hubble uses lots of different data points in order to create the beautiful, stunning, textbook rewriting images that we know today in the expanse of space. Okay, so once this is dry, I'm going to hang it on my fridge because I feel like it. And I'll see you guys in the next one. Bye-bye.